Today's lesson is about reviewing solving one-step equations. The objectives for today are I will be able to solve one-step equations with the addition and subtraction property of equality. The second objective is I will be able to solve one-step equations with the multiplication and division properties of equality. I'm Mr. Pilarski and I'm your host today. A solution to an equation is the value or values of the variable that make the equation true. We'll be solving equations today, looking for the solution to an equation. We'll be using equivalent equations, and equivalent equations are equations that have the same solution. And we'll see how equivalent equations come into play through example. And to solve an equation means to isolate the variable having a coefficient of 1 on one side of the equation. Going back to our objectives, thinking about that, we're going to be using properties of equality to isolate a variable, which that value that the variable is equal to is the solution to the equation. The first property we have here is the addition property of equality. It reads for any numbers a, b, and c. If a is equal to b, then a plus c is equal to b plus c. In other words, to maintain the equality, you must add the same number to both sides. For example, if I start with 6 is equal to 6, which we all know is true, and we add 2 to both sides, 6 plus 2 is 8, and 6 plus 2 is 8, and we see that equation is true, so we have to add to both sides. Now you see how I added it here. We could also move it down to here and put a line under it. Would be the same thing, adding 2 to both sides of an equation using the addition property of equality. Here's example 1t. We're asked to solve, which means we need to find the solution to this equation. We're going to create an equivalent equation. Now we can solve this equation since it's negative 23 plus x is equal to negative 16. We can solve that right away by adding 23 to both sides of the equal sign, or both sides of the equation. On the left-hand side, negative 23 and 23 are opposites. They become 0. They cancel. A lot of teachers use that phrase. I do too. Negative 16 plus 23. And if you use your calculator, you get 7. The reason behind that is we actually subtract the absolute values. 23 take away 16 is 7. And since the absolute value of 23 is greater than the absolute value of negative 16, the solution is positive. So we have our solution here that x is equal to 7. So we want to check that solution. We'll do our check over here in red. What we need to do for our check then is to substitute 7 in for x. So we have negative 23 plus 7, and that is supposed to equal to negative 16, and it does. Check. You can use a calculator there or just have good basic math skills there. Negative 23 plus 7 is negative 16. Moving on to the next example, example B. We have an addition equation, but it's really not an addition equation since we have a negative 4. We could rewrite this if we wanted to. We could rewrite this as x minus 4 is equal to 21. Either way, it's the same equation. It's an equivalent equation, one of our vocab words from the previous slide. So here, since we're subtracting 4, or we have a negative 4, we add 4 to both sides. These 4's are opposites. They go away. They cancel, if you will, leaving us x isolated on one side of the equation, and 21 plus 4 is 25. Again, we can perform our check by substituting in to our original equation. 25 plus negative 4 is supposed to equal 21, and of course it does. 21 is equal to 21, so our equation checks out. Our solution checks out. The subtraction property of equality reads for any numbers a, b, and c. If a is equal to b, and then a minus c is equal to b minus c. In other words, we must maintain equality by subtracting the same number from both sides. That's how we use the subtraction property, very similar to the addition property. Example 2t, solve the equation. X plus 12 is equal to negative 14. Since this is addition, we can use the subtraction property of equality, subtracting 12 from both sides. These 12s are opposites. 12 plus negative 12 or 12 minus 12 are opposites, leaving x on the left-hand side of the equal sign, or of the equation. The variable isolated with a coefficient of 1. And negative 14 take away 12 is negative 26. Negative take away negative always becomes more negative, so we add their absolute values, give 26, and since they're both negative, the solution is negative. So we have our solution there. X is equal to negative 26, so we substitute it in for our check. Negative 26 plus 12 is supposed to equal to 14. Negative 26 plus 12, since they're opposite signs, we subtract them. That does give 14, and it's negative since the absolute value of negative 26 is greater than the absolute value of 12. And negative 14 equals negative 14. Example B gets a little confusing for some students of algebra. Remember, a double negative always makes a positive. It's because the subtraction of rational numbers is defined in terms of addition. To subtract a number, in this case to subtract negative 9, we can add negative 9 to opposites, so that could become a plus. Plus, a double negative always becomes a positive. So solving this equation, x plus 9, we want to subtract 9 from both sides. The positive and negative 9 on the left becomes 0, leaving x isolated with a coefficient of 1 on the left. And here, negative 25 take away 9 is negative 36. So our solution is x is equal to negative 36. Check that solution real quick. Plug in the negative 36 into the original equation. Negative 36, take away a negative 9, equals negative 25. And again, doing the math here, negative 36 plus 9 is negative 25. So our solution is good. It fits our equation. Moving on to the second objective, we were going to talk about the 4 properties of equality today: addition, subtraction, multiplication, and division. Here we are at multiplication. The multiplication property of equality for any numbers a, b, and c. If a is equal to b, then a times c is equal to b times c. Just like the other properties, to maintain the equality, you have to multiply both sides by the same number. In the case of 4 is equal to 4, you may multiply each side by negative 2. Whatever you do to one side, you do to the other side, and that would give a negative 8 is equal to negative 8. So let's see how this works in solving equations. Now, in this equation here, we have x divided by 24 is equal to 5, and the opposite operation to division is multiplication. So we know we want to multiply both sides here, and we want to multiply by the denominator, in this case, 24. Multiplying both sides by 24. The 24s on the left divide out and become 1, leaving us the coefficient of, or the variable x with a coefficient of 1. And on the left-hand side, we have to multiply 5 times 24, and 5 times 24 is 120. So we have our solution, and we can perform our check. 120 divided by 24 is supposed to be equal to 5, and in fact it is. 5 is how many times 24 goes into 120. So our solution does check. The next equation, I know a lot of my students have been taught just to, since they have the luxury of a calculator, divide each side by 1/4, and that's totally okay. It would look something like this. And at this point, if you have the ability to do this with a calculator, that's great, because it is 1/4 times x, and we can use the division property here to solve. If sometimes you don't have that luxury, to get rid of this fraction, we just need to, since the numerator is 1, just multiply by 4, or its reciprocal, 4 over 1. The 4's will divide out, cancel, and become 1, leaving all 1's. So we have our variable x isolated with a coefficient of 1, and simply we have to do 12 times 4 to give 48. And then we do our math to check. Substituting our solution into the original equation would give us 1/4 times 48 is supposed to be equal to 12. And this takes a little simplification. This would give 48 over 4, which means to take 48 divide 4 and gives us 12 is equal to 12. So our solution does check. So that's the third property, the multiplication property. Let's move into the fourth. The division property of equality. For any numbers a, b, and c, if a is equal to b, then a divided by c is equal to b divided by c. It's good to note at this point that c cannot be equal to 0 because division by 0 is not allowed. It's undefined. So we have to divide both sides, just like the other properties where we added and we subtracted and we multiplied. We have to divide both sides by the same number. So here we have example 4t where we have to solve the equation. We need to find the solution. And since this problem reads -5 times x is equal to 60, we want to divide because that's the opposite operation of multiplication. And we want to divide both sides by -5. The -5's on the left cancel. They divide out, leaving x with a coefficient of 1. And 60 divided by -5 is -12. So our solution is -12. We have to substitute it into the original equation to check. So that'll give us -5 times 12 times -12 is supposed to be equal to 60. And in fact, it is. It should be a pretty basic multiplication fact. So our solution does check. And the last example today, -2.4 is equal to 1.2 times x. So we need to divide both sides by x. Or I'm sorry, by 1.2. Doing that division, that gives us -2.4 divided by 1.2, which does give a -2, is equal to x. Now, we need to use a property here, the symmetric property, meaning we can switch sides, saying that x is equal to -2. It's always better to put your variable first in your equation. So then we need to check our solution. -2.4 is supposed to be equal to 1.2 times -2. And even though this isn't real hard, 1.2 times -2 is -2.4. And it's real simple. You just do 1.2 times 2. 2 times 2 is 4, and 2 times 1 is 2. Since this has one decimal place, this needs to have one decimal place. And since one of them is negative, it's -2.4. So our solution does check. This has been Mr. Pi reviewing how to solve one-step equations with the addition, subtraction, multiplication, and division properties of equality. Thanks for watching, and have a good day.